Hi, my name is Ruszymah from UKM Web TV, and we are here today to talk to Prof. Ruszymah Idrus about skin engineering. Prof, could you tell us about your recent breakthrough in skin engineering?
Okay, thank you, Shahrizal. All right. Okay, how should I start with skin tissue engineering? Okay, actually, tissue engineering itself is a field, and it's a part of a field called regenerative medicine. We have successfully cultured or reconstruct is the skin. We culture them, and in the hope that we would be able to reconstruct skin that can be used for patient who has lost their skin in cases of burns, trauma, accident injuries, and in cases of ulcer, such as in diabetic ulcer, in bed sore ulcers, and other ulcers. We took about a year just to optimize the growth medium, the time, the temperature, and finally, at the end of 1 year, we managed to grow the cells. The skin has two cell types, the keratinocytes and the fibroblasts. Initially, we thought we could grow them together, but these two sets of cells are like two sets of human beings. When they are put together, they kill each other. So finally, we said, yeah, probably we should culture them separately and grow them in separate growth media. So we made it. And now, when we have grown enough number of cells, the two types of cells, we reconstruct them back into a skin. The lovely thing about this project is we can make a big piece of skin for the patient by taking a 1 × 3 cm squared piece of skin, healthy skin. We can make a 10 × 10 cm squared piece of skin to be used for the patient. So we've done on a few cases, on a few indications, and Alhamdulillah, it has been very successful. And now we are going further for a full-blown clinical trial.
What are the processes? Can you just explain it later?
Okay, the process. First, we have to take the piece of skin. Okay, to take the piece of skin, we have to digest because skin is a tissue. So we have to get the cells out from the tissue. So we have to use enzymes. The enzyme we use is called collagenase. So we actually, before you do this, you have to mince the skin small, very small, to 1 mm squared. You use an enzyme, you digest the skin, and you will liberate these cells. We then centrifuge a few times to get the pure cell. Then we culture this in an incubator. And this incubator has to be at 37 degrees Celsius, the body temperature. It's where our body cells grow. After the second digestion, we grow them in separate petri dish. The keratinocytes in their growth media, the defined keratinocyte growth media, and the fibroblasts in the dermal fibroblast growth media. We keep on growing them and passaging them. That means from 1 petri dish to 2 petri dish, and from that 4 petri dish to 8 petri dishes. So then we have enough number of cells for reconstruction of the engineered skin. And we also need to use a biomaterial in this case. So the biomaterial we use, and this is our own invention, it's from patients' own blood. It's the plasma. And the technology, how we extract this, has also been patented under UKM.
So basically you're saying you are taking the blood from the patient and making steam from it. It doesn't have to take any foreign like fibers and all
that. Yes, exactly. You are very right. This is what we want to emphasize. This product is autologous. Autologous means from you back to you. So it's your cell, it's your blood, and we are making a skin for you. There will be no problem or rejection. So that is what we want.
Conventionally, how burn patients of people with skin problems are treated?
Okay, at the moment, what we do is we actually slice off a piece of skin from the patient's normal part. Let's say the thigh. You can actually take a piece of normal healthy skin to patch up the skin loss in the injury site. So you will create a new area of injury where you harvest the skin. So that's the conventional treatment, and this treatment we call it a split skin graft. It's SSG. It's split skin grafting. So this new technology, this tissue engineered skin could be an alternative. When we test in our laboratory, this engineered skin secretes a lot of growth factor, very important growth factor that helps in healing. So in diabetic, they have this problem. They cannot heal as normal as we are. So their healing property is not normal. So they would probably benefit the most from this. The most difficult thing about producing this skin is we have to have this lab, this special lab. So you cannot actually do in any other hospitals. So the patient has to come over to Hospital UKM, get their cell culture and processed, and put it back.
I understand this is the first in the world?
Yeah, for bilayered and fully autologous. This is. You can't find, because if you go through the website, you will find people using collagen, and mostly the collagen are from animal source.
You have projects like, for heart. How is that going on?
Okay. Besides skin, we have a few other projects that are very promising. The next one that we are going to trial is the one for osteoarthritis, for the knee joint. Knee joint has two problems. One is sports injury, where the knee joint is focal. The other one is generalized. The whole part of the knee joint, when you get older, you have this sound in your knee. So we are trying to treat these two problems: focal injury in the knee joint and generalized injury in the knee joint, which we call osteoarthritis. We have done big animal study, and it has proven good. So the next is to do trial, and we need a lot of funding to do this clinical trial. And then after this, we are working on cornea, in the eye. Then that's now there's a problem of chemical injury, this acid splashed, so they get it to the cornea. The cornea becomes opaque. Cornea is the transparent part of the eye. So if it becomes opaque, you cannot see, light cannot penetrate, so you have to replace this cornea with a cornea from a donor. So but now we have the technology developed here. We can make this cornea from your own stem cell. If we can get a big drug company to fund the clinical trial, then probably they want to market it. Yeah. So it depends on how UKM is going to help us, how UKM technology and UKM per se is going to help us in this field to proceed. Because we are not this. I'm not a businesswoman. I'm not a business person. So I'm a lecturer, come a scientist and a doctor. So I want this research, what we develop in the lab, to be used on patients, and that is my dream.